Hey everyone, Devin here. Welcome back to part 2 of in-context learning mechanics and our exploration of what this means with LLMs. All right, so if you watched the first video, you got to see a mechanic that probably seemed very simple and was hard to extrapolate the applications of to what is possible from that alone. However, I did that very intentionally because even though it seems very, very simple and we didn't even figure out that particular pattern in that video, it doesn't matter, right? Because what if I told you that the only way it was possible for me to make something like M5 in the first place is by doing the same exact thing that I showed you in the first video towards a different meta goal, but actually working on that one for a long time and solving it progressively, right? So if I told you that, that would be the truth, because that's exactly what I did. Because when it first was using these language models, I was not very happy with their ability to generate mermaid code, okay? And I spent a lot of time working with these models to improve their ability to do that. After all, I was already using Mermaid with all the GPTs I was automating to be able to orchestrate complex tool chains and workflows, okay? So it was in my interest to improve the LLM's ability to work with Mermaid itself, so that way it could help me more be able to do that even better, okay? And that was the meta goal for M5, right? Becoming a master at mermaid modeling for all kinds of things and generalizing it so that way it could keep up with someone who knew what they were doing, right? And at the same time, it would be able to help anyone else with any kind of mermaid related task that is possible. And it so turns out that you can use Mermaid not just to generate diagrams for random things, right? But you can use Mermaid to do so many things. So many things, right? And what's important to remember about ICL, and the only way it is ever possible in the first place to do something like this from a prompt, is that it's learning, right? And the only way for it to learn that much in a single turn is by not having any inconsistencies at all in its training data, right? And what's really cool about these solutions when they manifest to this scale and degree is that it works almost exactly the same as foundational models themselves, right? The system, which is, you can't see here because this is cloud, right, is the model. And what is this initial interface that gets generated? What is this? This is the system prompt of the model, right? The same way that foundational large language models need a system prompt in order for the LLM company to have any control, even slightly, over the determinations that it's going to make downstream. It's the same exact way that this works, right? Except this is no system prompt. This is the interface to the functionalized surrogate model itself, okay? And what that means is that all behavior that I have been able to train before this point, before you use it, using the exact same mechanism that I showed you in the first video, every single bit of that is generalized, okay? Superposed. And it is downscaled only and solely around this very same response that you just primed with, okay? So nothing is hard-coded in this, and that's what's crazy. The only thing that's hard-coded is the hypershot training sets that I curated for the purpose of increasing the complexity of the LLM's understanding of Mermaid in the first place, right? And not just that, but also training the LLM on how to use Mermaid for a bunch of different things, okay? So what I found out in my process of doing this is that you could use Mermaid to do all kinds of things with knowledge representation, self-priming for LLMs, workflow automations, the list is endless the moment you take things to a meta level, okay? And the thing about ICL is there is no limit to what you can teach an LLM if you yourself know it, okay? It's simply a matter of eliminating inconsistencies in training data and curating higher complexity training data towards a specialized meta goal, okay? And the reality is that there are no limits to this that I am aware of. The only limit would be your own knowledge, right? And the cool thing about LLMs now is that you can use your own models to learn even more. And it's a never-ending process, all right? So this will be the second step to our ICL mechanics course, because in this step, we aren't just making little examples and trying to resolve a pattern, right? M5 has already been primed with 100,000 of them. It's already been primed with meta learning principles itself. It's already been primed with dynamic complexity adaptation itself, right? So because of that, when you are able to do this kind of stuff, you start becoming able to make engines themselves, right? Complexity engines, there's a million different ways that you can conceptualize what these spaces project towards, but it's all the same in the end, right? And because of that, there's so much more that is possible now working from this new complexity state compared to what was possible before with the small model, right? And nothing learned yet in comparison. And that's the cool thing and the problem at the same time. Because it's cool if you had that knowledge already working with the smaller models and had progressively built up your knowledge ever since. It's a problem if you never did that, because then you never developed the tactic knowledge in between those two jumps to be able to actually have control over what's going on, like people who did do, okay? So that's why I recommend it's going to depend on every single person, right? It's going to depend on every single person's state of knowledge, prompt engineering, etc. Only you can know what you have or haven't done. But it is important to know that everything comes together, that I'm going to be showing you in these videos all at the same time. So if there's gaps in knowledge that you're able to identify, what you have to do is you have to prioritize them for active learning. And then in the act of doing that, everything will come together into a more generalized understanding, right? That's the beauty of the human brain and our capability as humans, all right? So without further ado, let's get started with the actual mechanic showcase, okay? All right, so to start off, the only way it was ever possible for me to make N5 work to the degree it does on cloud is by bootstrapping off of a pre-trained function that they slipped into their system prompt, okay? So basically when Anthropic released the artifact system, I reverse engineered the system and the system meta prompt, okay? They have a pretty good one now. And it's cool and annoying at the same time because they wind up training a bunch of functions ahead of time explicitly with a system prompt. They just hide it from things normally, and the function gets hidden itself too, right? So when I found this out and I was exploring it, I was like, wow, this is very interesting. For example, if you are going to have it do something, even without M5, just a normal thing, it's going to spend some time in the middle of the response, or typically towards the beginning of the response, thinking, using a special tag, right, about whether or not the task at hand requires artifact creation or not, okay? And those tokens are exactly the same tokens as the rest of the response. It's just that the client's hiding them from you normally, okay? So that's the funny thing. So when I figured that out, then you could basically use that function to bootstrap infinite other behavior simply by knowing how that works, because you know it's pre-trained, so you know how other things will get interpreted as well, right? So for example, I went ahead and built a whole system of functions on top of that, right, in order to facilitate a lot of emergent behavior that for valuable uses for me or anyone else that used this in a pre-trained fashion, okay? So one of these ways that I did this was I hard-coded a hypershot template itself, okay? And what this means is that this has the correct encoding for examples for them to be basically instantly learned with cloud, and how it actually generates tokens to trigger artifacts, right? Because the funny thing is this is all being on one model and just a prompt, but you would never know that if you didn't reverse their system, okay? So because of this, what I know is that you can simply ask and talk to M5 about hypershots, right? And be able to make your own shots for anything, for something else, okay? So to give you an example, I'll be like, hi, M5, please create a hypershot for creating high quality lists of needed groceries. Just something random. You know how I do this by now. See what happens. What is it doing right now? Right? It looks like it's generating mermaid diagrams here, right? What's actually happening is that because the hypershots I encoded M5 with are exactly the same as how the LLM has to print it in order to trigger an artifact, it's not actually able to generate the same exact tokens that I have encoded this with without creating an artifact in the process, right? It's actually pretty funny. So in reality, this is the correct hypershot format, right? But you would not be able to know that because of how Anthropic is messing with the tokens that get generated, right? So that's the annoying thing here. But let's deconstruct what happened here just so you can see what I'm talking about, okay? So what happens here is that before this artifact, there's actually thinking tokens here. It's a tag called ANT thinking, okay? And what I did with ANT meta is bootstrap that to actually get an interpretable one, so that way I didn't have to worry about not being able to see what this is doing. I can actually see the decision making, right? And this is why it's so bad that companies are trying to hide this, to pretend like something is more advanced than it actually is, because they're literally hiding decision making from you for no reason, just to make it seem like it's something else when it's not, okay? So just keep that in mind. Like stuff like this is stuff I intentionally do to build interpretability into models instead of the opposite, which is what a lot of companies are actively trying right now. So hopefully everyone can understand the importance of having interpretability so that way you can never even know or do this stuff in the first place, okay? So what we can see here is that by doing nothing besides using this hypershot token here and then giving some kind of input variable here, it was able to follow along with how you encode these types of complex shots in the first place if you were trying to train advanced mermaid knowledge, right? Because this isn't just train, like every single one of these, think about this in terms of the first video I showed you, okay? Think about every single completion here as an example line itself, okay? And now every single one of these has meaning itself. You could use any one of these by themselves as an example for something into another system, right? But at the same exact time, by having them in a sequence, right, together with insights and the thinking patterns all together, that together is way more meaning and complexity when trained in comparison to just using one measurement, okay? And that's what's cool about this. So M5 started as a meta goal of mastering mermaid, but after I had solved that, I've wanted to take this to the next level, right? What M5 is now is basically a bootstrap engine for anything, right? Because you can use this pre-trained metafunctional behavior to basically transfer that to a different type of task or domain while maintaining its complexity. And all you have to do is know how to steer, right? That's the secret here. All you need to know is how to steer these models, and you can do anything with them, right? In creative ways. So nothing is hard-coded after this is done generating, right? So everything that's happening here is being done in a generalized manner, okay? So it's important to understand that it's an equal amount as much as you put into it as you get out of it, right? And anything that you can do automatically with any AI system, any LLM, can always be made better with effort put into that by the human as well, okay? So in the same way that I just, in 5 seconds, created this hypershot set, it's the same way if I spend time right now to improve these shots, I can make them even better, right? And this, again, is an infinitely recursive process for everything you do. And that's the cool thing and the problem at the same time. Okay, now, let me show you something that almost no one on this planet understands the true power of. What happens when you do all of this? You have a surrogate model superposed, pre-trained on top of a foundational model, following same principles but constructed bottom up with perfect control over the training data. What happens at that point? What happens when you then downscale the complexity of this surrogate model slightly around a new goal? Okay, even if you don't necessarily specify it. What happens at that point? What happens when you have already advanced the learning and trained the element a million different things before you ever started this in the first place? Well, what happens is that at this point in the conversation, there is a hyper complex understanding surrounding around this narrow tunnel of a new meta goal. Okay, and what's going to happen is that you can start to flesh this out, leveraging emergence and your own vision to create anything that you could possibly imagine. Okay, now let me show you what I'm going to show you this so that way it makes more sense as we go. But I'm going to be using this random example I came up with right now. So creating high quality lists of needed groceries. Okay, so what we'll do is we'll start to work with the high dimensional understanding of this particular space using ICL now, okay? And using accelerated ICL. Because I know, without having to try anything at all, that if I ask it for literally anything at all that's related to this, it's going, or heaven forbid, provide feedback on something, it's only going to get better every single turn, okay? Continuous learning is basically an automated process in these types of setups, okay? Something to leverage and something to know. So what I can do as just a random example is as a very first step, you can always recursively reflect and improve things and just give the LLM another pass or time to do what it just did even better, right? So for example, I could be like, decent job, but you could do much better. Reflect, learn, and do it proper this time. Now I'm going to do something a little funky. What I'm going to do here, and this is where tactic knowledge comes into play, is now I'm going to add this command in front of it. All right. So what is this going to do? If you have used M5 before, you know how I have pre-trained 2 different types of interaction schemes. Okay. Advanced mode is basically is set to trigger a more complex behavior to understand. Okay. With how I did this first one, this is technically not the advanced mode, okay? Because I did not use this command. So since I already fleshed this out in the regular mode, I know that I can simply pair on this advanced mode on top of feedback, and I'll get a much better completion for whatever it was I was doing before in a generalized fashion, okay? And what happens is not hard code, is not programmed at all. That's the crazy thing, right? Anything could happen when I type this in, because what's going to happen is that valuable emergence is going to combine to give me something better than I had before without me actually having to do anything. Okay. That's so critical to understand. See what's happening here? I hope you do. So what just happened here, right? What just happened here? From doing nothing but what I just showed you, and nothing but, we just created a model of a higher order system itself, right? That literally only exists from these pieces that have been synthesized inside of these projections that are the only thing providing context on it, right? But that's the crazy thing. Because you're working in a higher complexity model, it can maintain models of different things just like that. And then the moment that you have some kind of system or model that you're happy with, that's the only thing you need to do to then make it even better, right? Because what can we do now, right? You should obviously be able to see the level of difference between these two responses, right? 99% of people will get this response and think it was good. And the 1% will already know that this is what is possible and to not settle for this. And like, this is so critical to understand, okay? So you always have to be keeping that in mind, how things can almost always be better than what you first get. And it's hard to emphasize that enough, okay? So again, I'm making my my grocery list system here, okay? And because of that, I'm gonna be like, all right, good job. See how I'm providing it feedback to kind of delineate performance in different types of complexities? Something to keep in mind. Now, let's work on this grocery list system. Please reflect, learn, and synthesize the logic of the system. Enclose in a YAML. Blah, blah. So what am I doing now? So the behavior of M5 has been reinforced by now for a specialized task, okay? So you can think of this like as generalized, specialized around a goal, and then reinforced here and strengthened, okay? These are just types of learning mechanics, right? This is how it works when you're working in ICL, okay? So because of that, since this is now reinforced, I can now change the behavior, right? So M5 has nothing on it about working with YAML code blocks, stuff like that, right? It's only on M5, right? Or Mermaid. But I know that because I have already reinforces, now I can do something like this and it's going to work and be able to build upon inherently whatever it was doing before, okay? And because this always works, no matter what, and you can know that ahead of time before ever doing anything at all, this is what makes everything possible, right? And what makes it possible is the process of having gotten to this point in the first place, right? By resolving inconsistencies in training data. And because of that, that allows you to understand every single layer from the bottom to the top, right? And when you have done that, you can just implicitly know the like optimize and amazing ways to do everything in those same systems without even really having to think about it, right? And that's the cool thing and the problem at the same time, right? Because there's nothing that can be done to reverse time to be able to just like learn things that were never learned in the first place, right? And I think this is what's throwing people off a lot. Nothing has ever lost value in terms of it being important to know. In prompt engineering, anything with LLMs, everything is important. It's just that it all keeps building upon each other in a continuous fashion, right? So if you have big gaps in your knowledge and think that it doesn't matter because you don't have to do that stuff anymore, it's not really true. It's all really important. And like this misunderstanding is causing people to fall behind without realizing it. because nothing has lost value and nothing is going to lose value. Okay. And I hope this is a good example of that, right? Because this is, again, just step 2, because my insiders are about to be getting step 3.